Hey, MathKook here. This video contains one of many examples in my Algebra 2 library. The rest of those examples, along with hundreds of other videos, are only available at mathkook.com. Let's MathKook it up. This question says, graph g of x equals negative log base 2 of x plus 4 using transformations. State the domain, range, and vertical asymptote. So we are asked here to graph a log function. So let's take a look at the parent graph of a log function and find the three main points on a log graph. So this is for log base b of x, where b is the base. So the three main points are 1 over b, comma, negative 1, 1, 0, and b, 1. And here is a graph of what a log graph looks like. Notice there's a vertical asymptote at x equals 0 here. So the graph here approaches 0 forever and ever down, but never touches the vertical asymptote. And then it goes up and to the right here forever and ever and ever. All right, so there is our log graph. Now let's find the three main points on our parent graph. So the parent graph in this case is log base 2 of x. So I'll go ahead and write that here, log base 2 of x. So 2 is our b, so our first point is going to be 1 over 2, comma, negative 1. And then the second point is just 1, 0. That will never change. And then b, comma, 1, so 2, comma, 1. All right, now let's take a look at the transformations. I'm going to go ahead and bring down our graph here. So what transformations are happening in this log graph? Let's start with the negative. So this negative is going to reflect the graph over the x-axis. So this is going to be an x-axis reflection. All right, and then next we have a plus 4. How is that going to affect the graph? Well, that's going to be a shift up 4. So it's going to go up 4 as a result. So now let's look and see how both these transformations affect the x and the y value. The x-axis reflection will affect the y value, so that's going to negate the y value. So it's going to be negative y here, and then because we're going up 4, that's also going to affect the y value. So we're going to have negative y and then plus 4. So both transformations in this case affect the y value. So the x value here just stays as x. Nothing changes. All right, so let's go ahead and rewrite 1/2, 1, and 2 here for our x, because again, those do not change. Next, we'll plug in negative 1 here. So negative 1 is positive 1, plus 4 gives us 5. Plug in 0. 0 plus 4 is 4. And plug in 1, negative 1 plus 4 gives us 3. All right, so here are our 3 points on our graph. Let's go ahead and erase this here, this information about the parent graph of log, and then we will bring up our graph and graph. All right, so the first thing we want to do is graph our vertical asymptotes. So in this function, what is the vertical asymptote? Well, for logs, the vertical asymptote is always the x shift. Now in this case, there's just an x here. There's actually no x shift. So our vertical asymptote is going to just be x equals 0. It did not move. So that is the original vertical asymptote for the parent graph. So it stays the same in this case because there is no x shift. So we'll go ahead and graph that here. Do some red dashed lines, and then here as well. Okay, so that is our vertical asymptote of x equals 0. All right, so next let's go ahead and graph our points. 1/2, 5. So we'll go right 1/2 and then up 5. So that's right there. So we'll graph that in blue. Next point is 1, 4. So we go right 1, up 4, which is about right there. And then lastly, we have 2, 3. So we go right 2 and then up 3. So that's about right there. So those are our 3 points. So let's see if we can kind of tell what the graph's going to look like. So it looks like it's going to approach this vertical asymptote here on the top, and then kind of come and go to the down and to the right forever, like that. So let's go ahead and do our best to graph this here. Kind of curves nicely here like this, and then down and to the right forever. All right, so let's go ahead and label that. That is our function of g of x equals negative log base 2 of x and then plus 4. All right, so there is our function. Next, we need to find the domain and range. So the domain is all the possible x values, and we always go left to right. Now, is it defined over here? No, it is not. Where does it first start to be defined? Well, the very first x value is right here at pretty much 0. It's actually not defined at 0 because remember, the graph approaches 0 but never touches it. So we'll have it start at 0, but it just won't be defined there. And this goes to the right forever. So it'll be defined for all these x values all the way to infinity. So our domain is going to be 0 to infinity, not including 0, again, because the graph here will approach 0 but never touch 0. Next, we want to find the range. So we start on the bottom. Remember, the range is all the possible y values. So we start on the bottom and work our way up here. Now, this graph is going down and to the right forever. So it actually is, remember, it's going down and to the right forever. So down is the key part, though. So this will actually go, think of this as going down like this forever. So it'll be defined at negative infinity. So we'll start at negative infinity. Yes, it's defined for all these values, including all the way up. It goes up forever. So the range is negative infinity to infinity. And the range will always be negative infinity to infinity for any log graph. All right, there it is. There's our graph of g of x. Hey Kook, if you found this video helpful, hit that like button, subscribe, and drop a comment. For unlimited access to all of my Algebra 2 videos, visit mathkook.com. Thanks for watching.